All right, so we're going to talk about the expectations for benchmark number two. So for benchmark number two, this is going to be slide number 3. What I want is a screenshot of this slide complete and turned it into Google Classroom. All right, in order to complete slide number 3, what you need is the template. Now this template should be linked up on Google Classroom. I should have put it in and it should have the title benchmark number 2 on it. So this template will be given to you. What you're going to do is you're going to fill in on this first table right here Fox data, so the data that I gave you in the actual paper in the artifact prompt. You're going to insert your Fox data, and what's going to happen after you insert your data is that equations are going to start to pop up. And what you have right here is your sine function equation, here's your cosine, here is the tangent that we still have yet to explore, and then here is an old function that we've seen before. It's a linear model, quadratic model, and then right here is exponential. So it's a total of 6 different models that are going to pop up once you enter your Fox data. So below the Fox data, you have your rabbit data. You're going to go ahead and enter your rabbit data. So remember, for this artifact, scientists are only concerned about foxes, not rabbits, but we need the rabbit data because rabbit data is the food source for foxes, and that the food source of foxes, when it's low, it does affect the population of foxes because they might die out. So anyways, after you enter your rabbit data, you again have 6 different functions popping up. So this is what benchmark number 2 is going to be. So by the way, do make sure that you're logged in to your actual Desmos so you don't lose your data. So please make sure you sign in. Otherwise, you're going to have to re-enter this all over again and retake your screenshots. All right, so let's go back to my benchmark number 2 before this computer dies, right? 5%. So let's do this. Okay, so in this slide, what I want you to do is choose a model that is a bad fit for your Fox data. So let me repeat. I want you to choose a bad fit. If you remember from our vocabulary words, bad fit means that the line or the curve does not go through the data points well. Another way to say bad fit is that COD is bad. So COD being bad, if you look right down here, is this R squared number. So when the R squared is really far away from the number 1, it means it's a bad model. This one's really bad. See, negative 8.625. Right here, I didn't actually put a screenshot because I want you to put your own screenshot. So this is just an example. You're going to delete these screenshots and put your own. All right, so, and then there is a reason why there says linear, quadratic, or exponential up here. The reason why it says that is because these old functions that we studied before are not going to be good models to represent our data. If you've already guessed it, we're going to be using trig models to represent our Fox data. So either of these will work as bad models to represent your data. So you're going to choose either the linear, quadratic, or exponential. If you look back at your template, those are down here. These 3, that's linear, quadratic, exponential. You're going to choose one of those as a bad fit. And the reason why I want you to choose a bad fit is because I want you to explain and elaborate in your own words why it is a bad fit. So it's important to know why trig models are going to represent the data well and why our old models, old functions that we are used to, aren't good models. And that's what I want you to do, and that's the goal of this benchmark. So after you choose a model that's going to be a bad fit for your Fox data, I want you to, right here at the top, include a short description of the properties of that model. So for example, if you choose a linear model, I want you to talk about how it has an average rate of change, a slope, how it has a y-intercept. If you choose quadratic model, I want you to talk about how it has a decrease and an increase, and then there's a vertex, and then there's the y-intercept. So you want to talk about all of that. If you are to choose an exponential model, I want you to talk about percentage rate of change and its y-intercept and starting amount. So there's lots of juicy things you could talk about for all of these functions, and I want you to choose one though. So choose one that's a bad fit and then talk about it. Then, and here I have a little note right here, and I'm hoping that's in the template slides that you guys copied because I had this note quite a while. So after you choose your model and you include a little short description about the properties of the model, I want you to analyze this data. Now explain to me why this is not a good representation of the Fox data. And right here I put, when you choose a non-trig function, which is basically those 3, You must describe at least 3 properties and why those 3 properties don't match the real world data for the foxes. So why is it that the linear model is a bad fit? Or why is it that the quadratic model is a bad fit? Or why is it that the exponential model is a bad fit, using the math vocabulary and the properties that you know of that function. So that's what I want here. And then you want to go ahead and make sure you bring it back to foxes. Um, so and or rabbits if you want to talk about it. But what I want here is a screenshot about a bad model, and specifically let's do foxes. So choose for fox data, a bad model. And then you want to make sure you connect it back to what we're talking about. Connect it back to the relationship between foxes and rabbits, and do make sure that you include your screenshots and type out the actual equation of the function here. So Desmos is going to give you like the m and the b in this scenario down here. So hopefully this benchmark is clear to you. You do need your template. Make sure that you fill this out first. Enter the data from what I gave you, and then you should be able to analyze and complete benchmark number 2, which is just slide number 3 on this template. So there we go, we're at 3%. After you've watched this video, if you have clarifying questions, please make sure you raise your hand. I'll come by to support you to the best of my ability.